Just wanted to go through our assignment today. So we're going to have just a quick look at our appendix first. I'm just going to explain this concept here, and then we'll have a look and we'll give a breakdown of our assignment 2, or our assignment 1, AT2. So this here is in the appendix of lecture 11, looking at our drainage design layout. Really important. So this here is how we work out our head loss in our pits. So remember, as we look up our pipe network or looking upstream, we have our hydraulic grade line slowly drops down as a result of our friction loss. When it hits the pit, it runs straight, so we don't find out any loss in here. We assume all of our losses occur at the outlet side. So we have this massive drop in our hydraulic grade line here. Remember, if the hydraulic grade line is above our pipe, it will run full. If it drops below, our pipe will run half full or empty, depending on where the hydraulic grade line is. So we assume that if I was to put a piezometer in this pipe, my pressure reading will come up to this level. So calculating the shock loss, or the losses occur at the edge of the pit here, is really important, and we're using this graph or this diagram in here to calculate that, followed by another table. So what we can see is QG is the flow coming in from on top of the pit. This is a plan view, so this here is our pit top. QU is the upstream, so that's any flow coming from upstream, so from another pit or from any dwellings or any pipework or channel coming in up the top. QL is for our lateral pipes, or pipes penetrating through the side perpendicular to our flow. And Q0 or QO is what is coming out. That's our discharge flow from that pit. So important to get your head around, I guess, where things are coming into these pits. We had a brief look at that last week. So once we calculate, where these flows are coming from, the next thing we do is we look at this table here. Table 6.9, this is our head loss factors for pits. And this is obviously from this book here, Vic Roads 1995. Bit old, but it still works, still good. So we can look down here, we can see some notes that we're looking at. So QU is a flow from upstream, Q0 or QO is a flow out of the pit, QL is the flow from lateral pipes, the ones coming to the side, QG is a flow from above the pit water level, so what's coming in from on top, and K is our pit head loss coefficient. We've got some different pit types here, alright, but typically what you're going to end up with is an inlet pit with a through pipe. So that's usually what we look at, and that's something like this, ignoring the side pipes, so just a pit running one way and having pipes run through. Alright, so ignore these two here. We've got a pit up the top and a pipe running in and then a pipe running out. So that's typically what we're going to be dealing with. Now we've got Q0, QU, QL, QG. So depending on how the pipes are set out, we've got different combinations of them. Alright, we've got a bit of judgment we have to look at here. So let's have a suss. Alright, let's just run some numbers for now. If I have a pit, if I have a pit like this, if I come in here, if I've got QG, I have a pipe coming in, Q upstream, and my discharge Q0. Now, if I was to take, what are we going to use? Let's use, say, QG equal to 7.5 liters per second, QU equal to 7.5 liters per second. So 7.5 liters per second coming into the top of the pit, 7.5 coming in from upstream, which means what's coming out, Q0 is equal to 15 liters per second. So what use is that? Well, we've worked out some flows here. Well, from this table, looking at my inlet pit with a through pipe, well, QU, what's coming from upstream, is 50% of Q0, 70% of Q0, or 90% of Q0. In my case here, it is 50%. So if it's 50% coming in from upstream, what I can do is have a look just over here. This is my K value. So what I can do now is I've worked this out. So K is equal to 2.1. That's my head loss coefficient for the pit. So the shock loss that occurs in the pit, that's the coefficient that I'll use there. And what you know is the head loss in the pit, or the other side of the pit. So let's have a look. If I have a pit, something like this, pipe coming out of it, another one there. If I have my hydraulic grade line coming down across, so HGL, if I'm trying to work out how much this drops down by on the outside due to my shock loss, looking at this loss here is equal to, if you have a look at your notes, I think it's KV squared on 2G. This number here is the equivalent level drop here. Then my hydraulic grade line will continue through. So that's how we use these charts. Alright, so now let's have a look at our assignment, AT2. So coming through, alright, a couple things we need to look at. This is what you're going to get marked on. Alright, you've got to produce a report. You've got to discuss a couple of things in it. Obviously, calculations. Got a hydraulic design sheet we need to fill out. So that's this one here. We've gone through this. And then you need to obviously work out and do your longitudinal section sketch with your hydraulic grade line, pits, levels, and everything else. So we went through that last week. So this is our assignment here. Alright, so we're assuming curve and gutter grades 0.5%, that's the slope. We're looking at this example. Example, inlet spacing in lecture 11. Looking at the low side of the road. So let's have a look at this example then. Let's open her up. We are looking for, where's our work example? Cool, this one here. Let's go to the start of it. Alright, so inlet spacing. So we've gone through this example here. I hope you've all read it in your own time as well. But this time we're looking at the low side of the road. So just taking in half of the road width. So we already know from our low side of the road, we have a Q per meter of 0.12 liters per second per meter. So that's our starting point. Once we know this flow here, we can come in and we can go back through our appendix. We can look at our graded inlet spacing. And so from the low side, basically we can do this as well. We can work out initial pit, intermediate pit, and last pits. Alright, you can come through and calculate that based on the 80% capture, 90% capture, sorry, the 95% capture, and then you can space them out. So you'll be able to do that. So starting from here, looking at the low side of the road, this is our flow that we're dealing with. And so what you'll do is you'll come through, we go low side, let's write in black, so low side, Q is equal to, it was 0.12 liters per second per meter. That's our initial value here. Work out for 80% capture. Work out for 95% capture. Alright, work out what this is in liters per second. Liters per second. We can calculate this here from our appendix. So you can find the correct appendix, alright, that you might need to look at. A nice hint over here. Alright, once you've done that, what you can do and what you need to do, going by our assignment sheet, is you're going to assume a 50% blockage. So with a 50% blockage, calculate, well, alright, so assume 50% blockage, what is now my liters per second for these two scenarios. Once you've done that, what you're able to do is you can space your initial pit. So your initial pit is simply going to be whatever your blockage rate is. So you'll assume 80% for the first one, 20% bypass or something like that. And it will be whatever the collection is, that's in liters per second, divided by our flow, 0.12 liters per second. This will get you your first pit, so your initial pit, in meters, the distance. Work out your intermediate pit and your final pit. So this here is 80%, 80%, and a 95%. So you can go through it and calculate all of that. All right, so to show, I guess, diagrammatically, what's going to happen is if I have, this is my roadway. If I have pits sitting somewhere in here, so these here are my pits. If I have a pipe connecting them together, all right, I have some flow in this pipe, QU. I have some flow, QG, that's going to go into this pit. I will then have flow in this pipe here, QO, which then becomes QU. I'll have QG running into this pit. If this has 80% capture, 20% will run past and end up coming down here. Once you've calculated your flow running through these, what you'll then need to do is you'll need to come back and work out your hydraulic grade line as well, and do a sketch, as well as work out your hydraulic design sheet. So this one here. So you'll need to run through and work these out as well. What you'll find is when you run through the calcs, this will naturally fill itself out anyway. If you're unsure of the calcs, fill this out. Just sit here, go through these one by one, and the calculations will come together. Once you've done that, like I said, what you'll need to do is you'll need to draw your sketch, which will be something like this. All right, you'll end up with a surface level. All right, remember your surface is sloping at 0.5%, going by our question or our assignment sheet. Here, 0.5%. All right, these are your pipe works that you're using. All right, so you can come in, once you've worked out these, you can get your friction loss and other losses in there. So go back through your notes and you can find them. But looking at this 0.5%, what that means is if I have this point here as my RL of 100, my reduced level, if I have a pit sitting here somewhere, that's the lid coming down. All right, that's not a great sketch at all. Let's ignore that. If I have a pit sitting in here, depending on how far that is, that distance X, I can work out the level up the top. All right, it's going to be X times by 0.5% will give me, say, 99.73 meters up the top. I know so if that's where it starts, I know my shock loss that I will get because I'll have QG into this pit. We're ignoring any pipe work at the start. We're saying this is the first pit. QG comes in, I have my 300mm freeboard. Alright, go through your notes. We say that we don't allow it to be any higher than that. We make sure our water level is stationary or drops at that point. And then it will drop again due to our shock loss. And our hydraulic grade line will continue down. We will have pipes sitting somewhere connecting to another pit. Alright, you'll know this level here based on this distance, x2. This is our first pit, this is our intermediate pit. We know this point here based on our shock loss K factor. We look at our friction loss and we can work out this point here. Alright, this is due to friction in this length. It then runs straight across in our pit. We get shock loss again and the cycle continues. So this here is due to K because in here we have QG, and from here we have QU, and in our pipes again we will have Q0, QO going out. Alright, so you have to do this sketch here, obviously not like this. Make it accurate, put it on Excel, put it on CAD, however you want to graph it or draw it, go for it. And that's what you'll need to do, okay? The other thing that you'll need to have a look at is our minimum pit sizes. Alright, that there is also going to be important. You need to, if you're going to assume your pipe's going to be full, we might need to drop our pits further down to ensure that our hydraulic grade line sits below it. So that's our overview for our assignment. I'll let you guys have a crack at it. Any questions, I'll see you in class. Thank you.